Okay, so this is today's question. It's again a hyperboloid of revolution. It's an ordinary level standard one typically, but this is quite common at higher level in that they give you a hyperboloid of revolution in that it doesn't go up the full way. It's been cut off or it's slightly shortened. There's a few common mistakes that people make. So we'll start off anyways. We have 50 here for our hidden circle or throat circle. We have 100 here for our outside circle, and we're also missing a circle here, which we'll come back and make sure that we don't forget to put that in at the end. So obviously half of 50 is 25, so we need diameter 25, and half of 100 is 50. So I suppose we'll do the bigger one first. So here I'm just setting my compass at the back to 50. Okay, so we pull it about here and we'll see, let's zoom in then after that. Okay. So there's my center point, so I'll draw my crosshairs. Okay, and then we set it to 25, and we'll draw our hidden detail. Now we know from the plan view that this is hidden detail at this stage. So what we'll do is we'll try to get it accurate as we can and make sure that they hit the two edges off the crosshairs on left and right so that I can bring up those points. So the most accurate way to bring this up is by using, by using the outside edges. Okay, so typically what we do is we draw the plan first and then we draw this too. So we're going to leave a gap maybe of about 10. Black there to draw my ground line, and then the heights that we have are 55 and 25 in this case. Okay, and 25 is 80. So what I'll do is I'll draw that there. I'll just do that much first. This is my mark for my top part, so I'll just explain. There's a few various ways of doing this, so I'll try to explain all different ways of doing this. So if I look here, basically I should have a gap of 25 here. So because it's even, I wouldn't use the division in line method. However, especially if this is higher level, I probably would just do it on one side just to make sure that I can show that I have it done. But for today, we're not going to do it just to speed up the video a bit. So 5, 10, 15, 20 this way, and then this is 55 high. So again, 55 divides evenly by 5, so it gives us 11. So again, it's 11, 22, 33, 44. Again, I'd probably use division in line method on one of those sides just to show in case there'll be a mark for it. But basically, this here now is my V1 and my V2 point. So basically, this point is important and this is important. And one of the important things here is this is the rectangle that you're using. Often students accidentally try to split the whole bit here. Now, what I would usually say is that you've heard me say in class, is that I've never really thought about which one goes to which, because if I accidentally join these to V2 and join these to V1, they won't cross. So it must be the other way around. It must be these going to V2 and these ones here going to V1. So this is the rectangle method for doing a hyperbola. There is an alternative, two alternative methods for solving this, but this is the one I think is quickest and easiest, and usually it's the one students pick up the handiest. So I'll mark my various points so I can number these 1, 2, 3, 4, 1, let's see, that's wrong, 4, 3, 2, 1, so we're 1 and 1 cross getting point, 2 and 2, 3 and 3, 4 and 4. And that's like that. Okay, so I might just highlight these points here because I want to show them for my other side. Now, there's a few different ways then in terms of solving. I could repeat the same on the opposite side and do it. However, what I could also do, sorry, let's throw a bit more tape there, is I could also mirror across. Basically, hyperboloid of revolution is exactly the same on the top as the bottom and exactly the same on the left as the right. So what I'm going to do is I'm going to just draw these lines here, up and straight there, straight across. Okay, and the reason is the mirror method is good to get used to because it can be used to solve the top part in this case, particularly if the question isn't even. So that's the same distance on this side. As I said, this is completely up to yourself. You could use the same method as we used on the left hand side as on the right hand side. No problem with that. Okay. So we have our various points there, and now we can sketch this in. Okay, so the reason I showed that is because pretty much to solve the top, that's what you need to do, right? So I'll show you slightly in this corner an alternative way of solving the top, but would take up more space. So we knew that if we came up 25 more, that's going to be the top of my hyperboloid. We'll draw a line for that there. So if we came up 25, we actually need to know the exact point here. So what they would expect me to do in the exam is also come back down 25. So I have to draw a line here. Right? So that gives me that point there. And if I bring that up, that gives me the exact curve. So my curve is literally going to be sketching from there to there, but I have to show that I found the point in here to get full marks for that part there. So what I can do actually at this stage, if I wanted to, that's going to be the outside edge. So one of the lines that is missing in plan, and this is the top of the surface. So I can draw that and you'll see that in a second. If that's a little bit confusing for the minute, don't worry about it. So really all I need is another 2 points. So I have this one and I have this one. And again what I'll do is with my compass, let's see if that one might not be up high enough. With my compass, I'll take my distances. And again, because it's a mirror image on the top, there we go. There we go. So now I have all my points for that side. I can sketch that in. And again, the examiner would be expected to see that. And there's my left hand side completed. Okay, so I mirrored these up. As I said, I couldn't use this method, right, as it stands. Now, if I was hell-bent on using this method, or if I'd forgotten the day about the mirror method, I can use this, but it is critical that you don't get confused. So this is not typically the way I would do it, but just so people can see how you could do it if you wanted to. What I've done there is I've made the exact same size rectangle here. So I've measured up 55, which is the same as this. So basically this rectangle here is exactly the same as what I had. Right, maybe I'll highlight that in this light grey. So I have to make the exact same rectangle above as I had below. What most students will do will be, they'll get confused and they'll split this into 5 and split this into 5. And so their curve will come around and the full way out to there, which is incorrect. So if I do that, I can then do exactly the same as what I did here, but just the opposite around. So the 5 apart will be on the top. So 5, 10, 15, 20. And these would go to, because it's the opposite side down, these would go to a 2. And again, this will be 55. Then it'll be 11, 22, 33, and 44. And these are the opposite way, these will go to 51. So this is an alternative way. I'll just prove that it's symmetrical, but I would be less likely to use this method for this question. So 1, 2, 3, 4. So there's my 4 points. Now I'll just sketch them in maybe in a lighter blue, because it's going to be cut off. Okay. So there's my question. This would be this part here, and again that should technically be symmetrical of that, or that should be symmetrical of that. So you can use this method, but you have to draw the full rectangle, not just part of a rectangle. And again, if I bring this point here down, right, 90 degrees and straight, you'll see that that would line up with that. Okay, and that will give you that, and you can draw your circle. So this circle here is basically the top view of this, and that's another exceptional way of doing it.